Today I am hoping to do the questions and problems from Chapter 2. Let us start with the questions. First question is question 5. Question 5 says, in the figure, it gives a velocity of a particle moving along the x-axis. All right, let's draw it. Immediately what I notice is the velocity time graph. Got a little interesting shape to it. Let's get that on here. I think it looks something like that. And it's got some numbers, 1, 2, 3, 4, 5, 6. One, 2, 3, 4, 5, and 6. All right, there's the figure. It says, what is the direction of travel at time t equals 0 and 0.4? All right. Well, because this is a velocity versus time graph, what we can get out of this is, if we look, we see that the velocity at point 1 is a positive, and since it says it's moving in the x-axis, I would say that this is moving to the right. Here, because the velocity is negative, I would say it's moving to the left. At which of the 6 numbered points does the particle reverse its direction of travel? Ooh, that's a great question. That's a great question. So, if we consider it moving along the x-axis, if it's moving to the right, that would be a positive velocity. If it's moving to the left, that would be a negative velocity. But to go from positive to negative velocity, or from negative to positive velocity, you're going to have to switch direction. So I would say the answer to that is, I think it's switching direction at points 3 and 5. So when I look at this, this to me looks like it's moving to the right, getting faster. Now it's getting slower, stops, switches direction, getting faster. Now getting slower, stopped, switches direction again. And then D says, rank the 6 points according to the magnitude of the acceleration. All right, well, here's what we know. Because this is the velocity versus time graph, the acceleration is the slope of the velocity versus time graph, which is actually kind of cool because now I can just use my slopometer. For example, at point 1, it's at the local maximum, therefore the slope of the tangent line is 0, so here the acceleration is 0. Similarly down here, at point 4, the slope of that tangent line is 0, so the acceleration is 0. How does it want them? Rank the magnitude of the acceleration greatest first. All right. Now the magnitude is just the number. They don't care about the positive or negative. They want just the number. So the question is, where's the line the steepest? If I had to guess, I would say it's probably steepest at 2. Let's see what the picture looks like. So it's probably steepest at 2 and 6. Yeah. So I think, so I would say 2 and 6 are the greatest. Then 3 and 5. And then 1 and 4, and we know that those are 0. All right, that was great. That was number 5. Let's look at to number 7. It says, hanging over the railing of a bridge, you drop an egg with no initial velocity as you throw a second egg downward. Which curves in figure 221 give the velocity for the dropped egg and the thrown egg? All right. well, I don't know so much about the figure, but in my head, again, this is another velocity time graph. So if I think about it this way, if I just drop an object, there's a couple things you know. One, the initial velocity is 0. That's going to be important. And the second thing is that it's speeding up in the downward direction, which means that it's getting faster in the negative velocity direction. So I think for the dropped egg, it probably looks something like this. What I like about this question is that the second egg is thrown downward. And what does that imply then? Well, it implies it has an initial velocity, but it also has initial velocity in the down direction, so there's a large negative initial velocity. But the cool thing is, if I look at this graph here, regardless of the initial velocity, the acceleration is still the same for both eggs. So because it's a velocity versus time graph, those two should be totally parallel. Those are some excellent straight lines. All right. Let's move on to number 9 and get some board space. Nine says, a cream tangerine is thrown directly upward past 3 evenly spaced windows of equal heights. Rank the windows according to the average speed, the time, blah, blah, blah. Okay, so what we have here is we have an object, apparently a tangerine, that was thrown upward past these windows. Now, I think it goes past them, you know, in the up direction. So it looks like it goes right past them, and the windows are numbered 1, 2, 3. All right, A says, rank the windows according to the average speed of the cream tangerine while passing through them. Well, if you take an object and you throw it upward, as it's on the way up, it's going to be slowing down the whole time. So I think that, how are we ranking them? So 3, 2, 1. So obviously 3 would be fastest, 2 would be in the middle, and then 1 would be slowest, just by virtue of the fact that the ball is slow, or the tangerine is slowing down as it's on its way up. B says the time it takes for the tangerine to pass through them. Okay, no problem. If it's moving fast, it's going to take a small amount of time, a medium amount of time, and a large amount of time. So here I'm going to go 1, 2, 3. So, because again, it's because it's slowing down, you're going to have a long time on the top one and a short time on the bottom one. The magnitude of the acceleration as it's passing by them. Well, this is the only one that I think is interesting here, because if this is an object that's in free fall, it's on its way up, but only the Earth is pulling it down, then so here, if we're talking about the acceleration, they're all going to have the same acceleration because as the tangent goes up, the Earth is pulling it down. And regardless of the speed, the acceleration is still the same for all objects in free fall. Even if you're moving up, you're still in free fall. And then D says the change in velocity. Now, I really appreciate this question because the acceleration is equal to the change in the velocity divided by the time. And so to understand which of these is going to have a larger change in velocity, we have to understand not only which is going to have a larger acceleration, but also which one has a larger time. So for this one, to get the change in velocity, I can multiply these together. And so what we'll notice is that the change in velocity is proportional to the change in acceleration. So if you have a larger time, I'm sorry, I misspoke. The change in velocity is proportional to the time it takes to pass it. So a bigger time is going to give you a bigger change in velocity. So I think that would have to be 1, 2, 3. Because they have a longer time and the same acceleration, there's a longer change in velocity. All right. That wraps up the questions. Let's move on to the problems. First problem is number 11. First problem is number 11. You drive 300 kilometers to an interview. The interview is at 11:15. You plan to drive at 100 kilometers per hour, so you leave at 8 a.m. to allow some extra time. You drive at that speed for the first 40 kilometers. What would be the least speed needed for the rest of the trip to arrive on time for the interview? Okay, so this is annoying for a couple of reasons. One, they're not using meters and seconds. They're using kilometers and hours, which is super annoying because we don't have a really good sense of those things. And then they're giving these in minutes. So we'll see if we can't work it out. Okay, we'll see if we can't work it out. But one of the first things we want to do is we want to try to write down the things that we know. So let's start with what's given. First it's given, it says, you are to drive 300 kilometers to an interview. The interview is at 11:15. All right. So total distance. Okay. Second piece of information. You plan to drive at 100 kilometers per hour, so you leave at 8 a.m. to allow some extra time. All right, so you this is funny. All right, so you leave at 8 a.m. Okay. So interpreting these problems, just trying to figure out what you know and what you need to know, is half of the battle. So it says, you drive at that speed for the first 100 kilometers, but then construction forced you to slow to 40 kilometers per hour for 40 kilometers. What would be the least speed needed to get the rest of you? Okay, so let's see if we can do this. Let's see if we can do this in times of hours. That way we can do kilometers and hours. It might be easy. So if I leave at 8 and I got to get to 11:15, my total time, it's 3 hours and 15 minutes. So let's call that 3.25 hours. Is that cool? So the first thing it says is you drive at 100 kilometers per hour for the first 100 kilometers. Okay, so in leg one it says you drive at 100 kilometers per hour for the first 100 kilometers. I think this one is pretty standard. this statement here says for every hour you go 100 kilometers. So it looks like this took you 1 hour. Then, construction, it says forces you to slow to 40 kilometers per hour for 40 kilometers. So again, same process. If we're going 40 kilometers for every hour, and we go 40 kilometers, that's a whole nother hour. And now, we got to figure out leg 3. Okay, now we got to figure out leg 3. What would the least speed be needed for the rest of the trip to arrive on time for the interview? No problem. We know we need to go a total of 300 kilometers. We've already gone 140, so how much is left?